Hi everyone, welcome to this third video on Laplace transform. This third video is going to be the continuation of the properties of Laplace transform. We already saw about first shifting theorem and the formula for your derivatives of transforms. Now we will explore few more properties of Laplace transform in this video. The property we are going to see first is going to be called as integral of transforms, which says Laplace of f of t divided by t is nothing but integral from s to infinity Laplace of f of t into ds. So whenever there is a division, then it has to be integrated with respect to ds. Can we now apply it to a simple problem and see? Okay, let us find what is going to be the Laplace transform of sin t divided by t. By the property, what is going to be my f of t? My f of t is sin t. So this tells me whenever there is a division by t, I'll have to replace this division by integration from s to infinity. So the Laplace has to be taken only to my numerator. So it is Laplace of f of t with respect to the variable ds. So now this gives me integral from s to infinity Laplace of what is there in the numerator? Numerator has sin t into ds. Now we already know what is the Laplace of sin t. If it is sin, yes, there has to be constant in the numerator. What is the constant? A is taken by the value 1 over here. So it is 1 divided by s square plus 1 into ds. And we very well know the property that integral dx divided by x square plus a square. Do you remember this formula? This is nothing but 1 by a tan inverse x by a. So when we apply it in place of x, I have the variable s. So this gives me 1 by a. What is a? 1 by 1. Tan inverse of x. X is replaced as s by 1. So this has to be applied between the limit infinity and s. So now first let me apply the upper value or the upper limit to my s. So what happens now? I have this to be equal to tan inverse of infinity minus tan inverse of s. When does tan reach infinity? It reaches at your 90 degrees. So tan inverse of infinity makes it as pi by 2 minus this makes it as tan inverse s. What is 90 minus tan inverse of theta? I can write it as cot inverse of s. So I hope you now understood how to apply the property of division by t. If you have division by t, you will have to just integrate the function with respect to ds. Come, let us accustom with one more problem. Let us find what is the Laplace of e power at minus cos bt divided by t. So this is nothing but integral from s to infinity. As I see a denominator t, Laplace of e power at minus Laplace of cos bt, everything with respect to ds has to be integrated. So it is integral from s to infinity. What is Laplace of e power at? It is 1 divided by s. If it is plus a, then here it has to be minus a with respect to ds minus what is cos bt? If it is cos, then the numerator has to be s in the value. So it is s divided by s square plus b square, integral from s to infinity ds. Now let us integrate these two components separately. We know that integral ds divided by s is nothing but our log s. That is, whenever you have a quantity in the denominator, If the differentiation is available in the numerator, then you can take log. So what is s minus a's differentiation? S minus a on differentiation gives you ds. So the answer of this integration is nothing but log of s minus a. And what about the second quantity? Second quantity is nothing but differentiation of the denominator. What is the differentiation of the denominator with respect to s? S square on differentiation gives you 2s. There is an s, but what is missing is 2. So let me balance it by multiplying and dividing by 2. So now what happens over here? I have this as minus 1 by 2. Minus sign is already there. 1 by 2 times of log of the differentiation of the denominator in the numerator. So I can write it as log of s square plus b square. For the whole thing, I'll have to apply the limit between s to infinity. Now, in the next step, I can write it as log of s minus a. This half can be taken to the numerator because I know a log b can be written as log of b to the power of a. So, this half can be taken to the numerator as log of s square plus b square whole power half with infinity to s. Whole power half, how I can write it as log of s minus a minus log of square root of s square plus b square. This is how I can write the values from half over here in my numerator. Now I know log a minus log b can be written as log of a divided by b. What is my b? Square root of s square plus b square. Okay. And now let me apply infinity and s. On applying infinity directly, what will happen? This will become infinity by infinity, which is an indeterminate format. So what do we do normally is we pull out an s from the numerator, in which case I have 1 minus a divided by s. Now as s tends to infinity, 1 by infinity will move towards 0. So this component will become 0. Now how to vanish of this s? Again in the same manner, pull an s square from the inside the square root. When s square comes outside the square root, it comes out as s. So what will be left inside the square root? 1 plus b square by s square will be left out. Now, what happens is, as I apply infinity to s, this s and s cancels off. 1 by infinity will move towards 0 and how I will have only log of 1 divided by, this will move towards your infinity. 1 by infinity moves towards your 0. 1 plus 0 makes it as 1. So, it will be log 1 divided by 1. So, this becomes my upper limit. Minus, what about my lower limit? Lower limit becomes log of s takes the value s. So, it is just 1 minus a by s divided by root over 1 plus b square by s square. What do we know about log 1? Log 1 is going to be equal to 0. So this moves towards 0. And this will be the content which remains for us. But there is a negative sign. What can be done about the negative sign? Take it to the numerator. So when I take it to the numerator, what will happen? Numerator will become denominator and denominator will become numerator. That is, it flips. So what happens over here is minus log of, what you have is 1 minus a by s divided by root over 1 plus b square by s square. I take it to the numerator of it. So this becomes log of 1 minus a by s divided by root over 1 plus b square by s square whole power minus 1. What will this minus 1 do? It will flip my data. So this gives me the final answer as log of root over 1 plus b square by s square divided by 1 minus a by s. I can further simplify this as log of root over s square plus b square divided by s minus a. So, we have found out how to apply the quantity called as division by t by replacing it in integrals for my Laplace of the quantity. Thank you.